Once again, welcome to my YouTube channel, Pearson at Excel International Maths by Mr. Kamoto. And we've just introduced ourselves to Algebra 6, and this is video number 2 of that particular topic. This is video number 2. This is video number 2. The other one was video number 1. And we've just understood how we can relate direct proportional variables, and we have just understood that we can write them. Y is directly proportional to x, which changes to y is equals to kx, and of course k is a constant that needs to be evaluated or found. We have a practical example, example 1, which is saying that the extension y of a spring is directly proportional to the mass x. Y is directly proportional to the mass x. You know, we are talking about, we can even start from the origin, whereby we can even say the extension is directly proportional to the mass. Now, it's only that y means extension and x means mass. And at this part, before we do anything, it is important to rewrite this one in an equation way or in an equation form, having now to introduce is equals to k. So this one can directly or straightforward be written is equals to y is equals to kx. Whatever the value of x is equals to whatever the value of y is, it is equals to kx, where k is the constant of proportionality. If y is 12, now this is now a very important point. Details. Of course, there is no way we can get the value of y, neither the value of x, if we do not have the details. When y is equals to 12, x is equals to 3. We must have that in mind. Part A, find the formula for y in terms of x. Listen and listen well. This is exactly the same as the question we were facing in exam practice 1 and question number 1. Find the formula for y in terms of x. At that point, we must take the value of y and the corresponding value of x and substitute them in what we believe is an equation of direct proportionality. So when y is 12, is equals to of course, the constant of proportionality maintains, but x is 3k. I mean, it's more mathematical to write 3k other than k3. 3k sounds better. K3, the same thing, but of course, it looks like it's a name of a certain house or something. K3 or something, but 3k is quite understandable. So if we want to get the value of k, which we must find, we divide everything by 3 and everything by 3, and you will agree with me that k is a 4. So the equation, straightforward, is when we substitute k in this equation of proportionality, it gives us now the equation, the formula for y in terms of x is y is equals to 4x. Somebody can ask us, why are we writing 4 and y is still maintaining to be y? Remember, k is equals to 4 and k itself is a constant. A constant does not change. This one is a variable. Y is a variable. Y is a variable. These are variables. Y and x are variables. Well, this 4 is a constant. And constants will never change. It will remain constant. But y will change so long as x changes. X will change so long as y changes, because in the question we are told that y is directly proportional to x. That is as far as part A of the question. So yes, this is the formula for y in terms of x. Part B, that is part A. Part B of the question, find the extension y when a 7 kg mass is attached. Now, we have x, we need to look for y. And because we now have the relationship, this becomes the easiest thing to do. So y is equals to x, which we are finding, but k remains the same, 4x. It's x we want to find. Now, find the extension y when we have a mass of 7 kg. So in this case, x is equals to 7. So our relationship becomes y is equals to 4 times 7. And of course, it goes without saying that the extension is 28 centimeters, so to speak. It's just like that. It's just like that. What about part C of the question? Find the mass x that produces a 20 centimeter extension. It is now why we are looking for. Find the mass x. It's the x we are looking for. Find the mass x when y is 20. So we start by saying 20 is equals to 4x, because in this case we know the extension, which is 20. What we don't know is actually the x. And of course, in both sides by 4, it produces that x is 5 kg. That is as simple as that. So if the mass is in kg, so we are saying that a mass of 5 kg produces 20 centimeter extension. And if you want to present this graphically, probably you may have something like extension and the mass. This is extension and this is the mass. When we have mass 0, extension is 0. But when we have mass increasing, extension also increases. And this is the equation of the line y is equals to 4x. 4 happens to be the gradient, but yes, it is a straight line. So that is it. We've been able to explain everything in example 1 very amicably, very competently. Please follow, visit my YouTube channel, and of course subscribe and share widely, and let's move together. All right.